Our lesson today is on solving rational equations. And the steps that we're going to take in doing this are finding a common denominator. We're actually going to multiply both sides of the equation by that common denominator. So let's make that note. We also need to make sure that we have factored the denominators as well, if they need factoring, and that would actually be even before finding a common denominator. So factor denominators if necessary. Not every question will have a denominator that needs to be factored, but if it does, that would be your first step, okay? And once we have multiplied both sides by common denominators and factored our denominators, then we can state our non-permissible values. Then we're going to try and isolate the x on one side, and that will actually allow us to eliminate the denominator, and we'll be able to solve for x. Okay, so you'll see what I mean as we do a few examples together. Okay, the first one is x over 2 minus 2x plus 5 over 4 equals 4 over 3. Okay, so when I look at these three numbers that I have in the denominator, remember I have to find a lowest common denominator that all three of those are factors of. Okay, so the lowest common denominator that I can find would be 12. So that means I'm going to multiply both sides of this equation, both sides of this equal sign here, by 12. So I'm going to multiply this side by 12. I'm going to multiply this side by 12. And when I do that, it means this whole part here by 12. So I have to remember then that that means I'm going to multiply the first term by 12 and the second term by 12. So 12 times x is 12x, and that'll be over that's 12. I'm multiplying by 12, so that's really 12 over 1, right? So when I multiply that, that's 12x over 2 minus, and then 12 times 2x minus 5, or plus 5. So 12 times 2x is 24x. 12 times 5 is 60, and that's all over 4. And that's going to equal 4 times 12 is 48 over 3, because this is really 12 over 1. So 4 times 12 on the top, 3 times 1 on the bottom. Okay. Now when I do that, I can see right away that I can do some simplifying here. If I divide a common factor out of both numerator and denominator, I can divide by 2, and that leaves me 6x on the top and 1 on the bottom. So I don't even need to write that one. I also can see that in this next expression, I can divide out a 4. When I do that, I have 6 left there, and I have 15 left there. So that leaves me with minus 6x plus 15. And that equals, and on this side, if I divide a 3 out, that's 1 and 16 on the top, equals 16. And so you can see how that eliminates my denominators totally when I multiply both sides by the common denominator. Okay. So this would really be 6x minus 15 equals 16. When I do this, I have 6x minus 6x, that cancels each other out, and so I really have 0 equals, if I add 15 to this side, because I've added 15 to that side, 31, there is actually no solution to this question because this answer does not even make sense. It's not solving for x. That is a funny one for them to give us to start with, but every once in a while you will find one of these that has no solution, and no solution is your answer. Okay, let's try the second one. I have on one side a denominator of x plus 3. What's my denominator on the right side? Right, it's over 1. Okay, so my common denominator is going to be x plus 3. So what that means is I'm going to multiply this side by x plus 3, and I'm going to multiply this side by x plus 3. That's really x plus 3 over 1, right? Like, you don't have to put the 1 in, but it might help me when I'm multiplying straight across the numerator and straight across the denominator to remember that. Okay, so on the top over here I've got 3x plus 9, and that's all over x plus 3. And on this side I'm going to have 6x plus 18, and that's all over 1. Okay, and if I keep going, I see here that I have a common factor that I can factor out. This is actually 3 times x plus 3, and that's all over x plus 3. And on this side, I've got 6x plus 18 over 1, which I don't even have to write the 1. This x plus 3 will cancel this x plus 3, so I'll really be left with 3 equals 6x plus 18. Okay, if I solve for x, I'm going to subtract 18 from both sides. So I'm going to have negative, subtract 18, yep, negative 15 on this side equals 6x. X is going to be negative 15 over 6. And that's my final answer. Now, because this one did have an x term in the denominator, I do need to state non-permissible values for x as part of my answer. So I also have to say then that x cannot be negative 3. That's part of my answer as well. Okay, next question. This is at the top of your next page, and it's 3 over x plus 3 equals 9 over 4x plus 7. Okay, now my common denominator, remember, is going to have this as one of its factors and this as the other factor. So my common denominator is going to be x plus 3 times 4x plus 7. So I'm going to multiply both sides of my equation by x plus 3 and 4x plus 7. Okay, so on this side, I guess I don't need to make my bracket quite that large. X plus 3 and 4x plus 7. And I'm going to do the same thing on this side, multiply it by x plus 3 and 4x plus 7. Okay, and what I end up with then, when I multiply this out, is I have 3 times x plus 3 times 4x plus 7. And that's all over x plus 3. And on this side, I've got 9 times x plus 3 and 4x plus 7, all over 4x plus 7. Okay, now you can see that this x plus 3 will cancel this x plus 3. This 4x plus 7 will cancel this 4x plus 7, which allows us to get rid of our denominator. And what we're left with is 3 times 4x plus 7 on this side, and 9 times x plus 3 on this side. Now I need to solve for x, so I'm going to multiply this out. So this is 12x plus 21 equals 9x plus 27. Okay, I'm going to subtract 9x from both sides, so I'll have 3x left on this side, and I'm going to subtract 21 from both sides, and I will have 6 left on this side. X is equal to 2. Now, because I had x's in my denominator, I do need to tell my non-permissible values of x. So x cannot be -3, and x cannot be, well, if we set 4x plus 7 not equal to 0 and solve for x, then I have 4x cannot be -7, x cannot be -7/4. And this whole thing would be my completed answer. Okay, the next question does have a denominator that I am going to have to factor. I can see right here that there is a common factor in, or a common factor that I can factor out of this binomial, and that's the x. So I'm just going to rewrite the equation, but I'm going to factor the denominator. So I'm going to factor out an x. So I've got x minus 3 times x. That equals 6 over x minus 3 minus 5 over x. Okay, now my common denominator, I can see at a glance, is going to be x times x minus 3. Okay, so I'm going to multiply both sides by that. So this side I'm going to multiply by x. Oops, I keep making my bracket that big. I don't need to do that. X times x minus 3, and I'm going to multiply that by this whole side here. Remembering then that that means I have to multiply the x times both terms and the x minus 3 times both terms. Okay, and I'm going to do the same thing on this side. I'm going to multiply x times x minus 3 times this whole thing. Okay, all right, so when I do that, I've got this. I'm going to have 18 times x minus 3 all over x times x minus 3. And on this side, I'm going to first start with the x, and I'm going to multiply the x by both terms. So I will have 6x Okay, so I'm multiplying the 6 by the x, but then I'm also going to multiply the 6 by the x minus 3. So then I would also have 6 times x and n times x minus 3. And that's all over x minus 3. Then I'm subtracting 5 times x minus 3. And that's all over x. Now I can see that my x cancels my x minus 3 cancels my x minus 3. This x minus 3 cancels this x minus 3. This x cancels this x. So I'm going to be left with 18 equals 6x minus 5 times x minus 3. Okay, when I keep that going, I've got 18 equals 6x. Now I'm going to multiply this -5 by the x and by the -3, and I end up with plus 15. Now, if I combine like terms, I've got 18 equals 6x minus 5x is just x, plus 15. If I subtract 15 from both sides, I've got x is equal to 3. Okay, now I do need to go back to my factored form and figure out what my non-permissible values of x are. So I can see right from here that x can't be 0, x can't be 3. Same thing on this side. X can't be 0 or 3. Now that is a problem because my solution said that x is 3. What this means is that there is actually no solution to this question because this is a non-permissible value of x. Okay, so when that happens, then we just say, therefore, there is no solution. All right, let's try a couple more. we've got 4 plus 2 over x. This is really 4 over 1, right? This equals 6 over 1 plus 3 over x. I can see that my common denominator in this equation is just going to be x times 1, which is just x. So I'm going to multiply this side of the equation by x, and I'm going to multiply this side of the equation by x. When I do that, I have 4x over 1 plus 2x over x equals 6x over 1 plus 3x over x. I can see right now that this x will cancel this x will cancel this x. So what I really have left on this side are 4x plus 2 equals 6x plus 3. I'm going to subtract 4x from this side, subtract 4x from this side. I'm going to subtract 3 from this side, and then x is equal to negative 1/2. Then I go back to my original equation and I say x cannot equal 0. That's my non-permissible value for x. Okay, the next example, I've got an x plus 1, an x minus 1, and actually I've got a 1 in the denominator on this side. Okay, so my common denominator is going to be x plus 1, x minus 1. So I'm going to multiply both sides by that. So this side I'll multiply by x plus 1 and x minus 1. And this side I'll multiply by x plus 1 and x minus 1. Okay, when I do that on this side, I've got 3 times x plus 1 and x minus 1. And that's all over x plus 1. Plus, I've got 1 that I have to also multiply by both of those. This whole side is being multiplied. So I have to multiply them by that term, but also by that term, right? So I've really got 1 times x plus 1 and x minus 1 all over x minus 1. And that equals 2 times x plus 1 and x minus 1. Okay, now is the fun part. We get to cancel those terms in the numerator and denominator out. We get to cancel those terms in the numerator and denominator out. And in essence, wipe out our denominators. Okay, so what we're left with is 3 times x minus 1 plus x plus 1 equals 2 times x plus 1 times x minus 1. So first, let's FOIL those and figure out what that equals, and then later we'll multiply it by the 2. So we'll leave the 2 here, and we'll say x times x is x squared. I've got negative x plus x. They cancel each other out, and so then I've got positive 1 times negative 1 is negative 1. Okay, multiplying 3 times x minus 1 will give me 3x minus 3 plus x plus 1 equals, now I'm going to multiply the 2 by x squared minus 1. So I've got 2x squared minus 2. Now I'm going to collect like terms. I've got 3x plus x, that's 4x. Negative 3 plus 1 is negative 2 on this side, equals 2x squared minus 2. Okay, I need to get all of these, because I see this x squared term, what this tells me is this is one of the type that I am not going to be able to just solve for x. I'm going to have to get all terms over to one side and make it equal to 0. Okay, so to do that, I'm going to keep my 2x squared on this side, and I'm going to try and bring this 4x over by subtracting 4 from both sides. So that's going to give me negative 4x on this side. And then I'm going to add 2 to this side. So I'm going to add 2 to this side, and that will give me nothing. So I will have 2x squared minus 4x equals 0. Now I see a common factor here that I can factor out, so I need to do that next. So that's the same thing as saying 2x times x minus 2. So what this means is that this term cannot equal 0 and this term cannot equal 0. So I'm going to set both of those to 0. So 2x is either equal to 0 or x minus 2 is equal to 0. I'm going to divide by 2, so 0 divided by 2 is still 0, and x minus 2, if I add 2 to both sides, x is 2. Okay, so I've got two possible solutions. Either x is 0 or x is 2. Well, the way that I can figure out what my answer is, or could be, is that I have to go back to my original equation and make sure that I've accounted for what my non-permissible values of x are. Because if I find out that x can't be equal to 0 or 2, then I'll know that one of these two solutions is extraneous. That means it doesn't make this equation possible, or is not a real solution, and so I would count that solution out. Okay, but when I do go back to my equation, I can see that the only values that x cannot be are x cannot be equal to positive or negative 1. Okay, so I do have two solutions. X is 0 or x is 2. Either one of those will make this equation true. Right, moving right along here. Next question is denominator of 3x minus 1 and a denominator of 3x plus 1. And of course on this side, this 1 is really over a denominator of 1. Okay, so obviously my common denominator is going to be 3x minus 1 and 3x plus 1. So I'm multiplying both sides by that. I'm going to remember to multiply this whole thing by that. 3x minus 1 times 3x plus 1. Okay, when I do that, I have on this side 5 times 3x minus 1 times 3x plus 1 all over 3x minus 1. Plus, then I'm doing 3x times 3x minus 1 and 3x plus 1. And that's all over denominator of 3x plus 1. And that equals 1 times 3x minus 1 times 3x plus 1. Okay, now comes the fun part. We get to see what will cancel out to get rid of our denominators. And we can see what we're left with. We're left with 5 times 3x plus 1 plus 3x times 3x minus 1, and that's going to equal 3x minus 1 times 3x plus 1. Let's multiply that out right now and see what that is. 3x times 3x is 9x squared. Positive 3x minus 3x cancels each other out. Negative 1 times positive 1 is negative 1. Okay, now we have some canceling out, or sorry, some multiplying to do here. 5 times 3x plus 1 is going to be 15x plus 5, plus 3x times 3x minus 1 is 9x squared minus 3x equals 9x squared minus 1. Okay, I have to collect some like terms. I've got 15x minus 3x, so I've got 12x plus 5 plus 9x squared on this side, and then on this side 9x squared minus 1. Okay, now if I try and bring all of my x squareds over to one side, I'm going to subtract 9x from this side, which subtracts 9x from this side. Really, they will cancel each other out that way. So I will be left with 12x plus 5 equals negative 1. 12x, I'm going to subtract 5 from both sides, equals negative 6. x equals negative 6 over 12, which is negative 1/2. Okay, and if I go back to my original equation to see what my non-permissible values of x are, and I set them equal to 0, I've got 3x minus 1 cannot be equal to 0, so 3x cannot be equal to 1, and so divide by 3, x can't be 1/3. If I set the other one, 3x plus 1, not equal to 0, and solve for x, I've got 3x cannot be negative 1, x cannot be negative 1/3. So in other words, x cannot be positive or negative 1/3. And that would be my final answer. Okay, I'm just going to erase this so that I have this space to write in here, and I hope you've caught up to this point. I'm just erasing this. If you need to see this, you can back the video up and to the point where you need it. I just need a little bit of space here to write. Okay, in this equation, I have a denominator of 2x plus 3 and a denominator of x plus 7, and on the right side a denominator of 1. Okay, so I'm going to multiply this side by 2x plus 3 times x plus 7, and I'm going to do the same thing on this side. I'm going to multiply this side by 2x plus 3 and x plus 7. Okay, now when I do that, I have to remember that it's this whole side that I'm multiplying by both of those things. So I've really got 8x times 2x plus 3 times x plus 7, and that's all over 2x plus 3, minus x plus 3 being multiplied by 2x plus 3 and x plus 7. And that's all over x plus 7. And that equals 3 times 2x plus 3 times x plus 7. Okay, now's the fun part. What cancels what? 2x plus 3 cancels this 2x plus 3, x plus 7 cancels this x plus 7. No more denominator. 8x times x plus 7 minus x plus 3 times 2x plus 3 equals 3 times, let's multiply this by using FOIL, 2x times x, 2x squared, 14x plus 3x, 17x plus 21. All right, now let's multiply 8x times x plus 7. We'll have 8x squared plus 56x minus, then we have to multiply x plus 3 times 2x plus 3 using FOIL. So x times 2x is 2x squared plus 3x plus 6x is 9x. 3 times 3 is 9. And that's going to equal, now I have to multiply 3 by each term in this trinomial here. So 3 times 2x is 6x squared plus 3 times 17 is 51x. 3 times 21 is 63. Okay, now we have to combine like terms. 8x squared minus 2x squared is 6x squared. 56x plus 9x is 65x. And then plus 9 equals 6x squared plus 51x plus 63, Getting some pretty big numbers in this one. Okay, so again, I'm going to subtract 6x from this left side and bring it over, subtract it from the right side. 6x minus 6x squared minus 6x squared leaves me with 0, so I don't have any x squared term. I'm going to subtract 51x from the right, subtract 51x from the left. So subtract 51, that's going to give me 14x on the left. Then I'm going to subtract 9 from the left, so I subtract 9 from the right. 63 minus 9 is 54. And if I divide both sides by 14, oh, you guys, I just noticed a mistake I made. I'm afraid we have to go back to this step right here. I hope you have your erasers handy. Sorry about that. Those negative signs can be nasty, because this negative sign here is actually meaning minus whatever you get when you multiply these two binomials. And so that's going to change some signs. I knew something was wrong, something was not looking right. So coming back to this point, let's multiply 8x times x plus 7. We've got 8x squared plus 56x. Then we have minus whatever this gives us when we multiply it out. X times 2x is 2x squared. 3x plus 6x is 9x. 3 times 3 is 9. Okay. Now this will totally change everything because we're subtracting this whole amount here. And so this means it's really negative 1 times 2x squared, and negative 1 times 9, and negative 1 times the other 9. So that is going to do some sign changing in the middle there, which we'll deal with in a minute. And then back to this, 3 times 2x squared is 6x squared plus 51x plus 63, like we had before. Okay, so let's just go, and now we will distribute this negative 1 that's here by each term in this trinomial there. So we've got 8x squared plus 56x minus 2x squared minus 9x minus 9 is what that would make it. You have to really watch those negative signs, those subtracting signs. It means minus this whole amount. And that was my mistake. I'm sorry about that. 6x squared plus 51x plus 63. Okay. Now when we combine like terms, we have 8x squared minus 2x, which is 6x squared. We've got 56x minus 9x. So that's going to be 47x. And then we've got minus 9 equals 6x squared plus 51x plus 63. Okay, again, if I try and subtract 6x squared from this side and subtract 6x squared from this side, they will cancel each other out. So really I have 47x on this side, I've got 51x on this side, so I'm going to subtract 47x from both sides, and that will give me 3x on this side. And then I'm going to subtract 63 from this side and subtract 63 from this side. So that's 72. Negative 72. Oops, sorry. this is 4x, not 3x, because 51 minus 47 is 4x, sorry. And then divide by 4, so x is going to be negative 14. There, that looks better. Oh, my goodness. I don't have my calculator handy. Sorry, guys, I'm trying to do this in my head. You have your calculator. 72 divided by 4 is 18, not 14. Sorry, negative 18. Okay, then I need to go back and look at what my non-permissible values for x can be. X cannot be negative 7. And then if we set the other term, 2x plus 3 equal to 0, x can also not be negative 3/2. And this is my answer. Okay, we are almost done. We have just a couple more to try, and then you'll have a chance to practice some of these on your own. Okay, when I look at this next question, I notice right away that I'm going to have to do some factoring in the denominator of the right-hand side of my equation. Okay, so I'm going to leave my left-hand side just as is and rewrite it exactly like it is. X over x minus 3. And on this side, I have 18 over. Now this is a difference of squares. I have x squared, which is a perfect square, and I have 9, which is a perfect square. And when I have a difference, a subtraction of two perfect squares, that's the easiest question to factor, because I just find the square root of x squared, which is x. I find the square root of 9, which is 3, and one of them I add, one of them I subtract. X plus 3, x minus 3. Okay, now I can see right away my common denominator is going to be x plus 3 times x minus 3. So again, I multiply both sides of my equation by x plus 3 and x minus 3. Same thing over here, multiply this by x plus 3 and x minus 3. And I have to remember that it's this whole side of the equation that I'm multiplying by that. Okay? When I do that, I have 2x times x plus 3 and x minus 3. And that's all over x plus 3. Plus, I have to multiply the x now by both of those. X times x plus 3 and x minus 3. And that's all over x minus 3. And that's going to equal 18 times x plus 3 times x minus 3. And that's all over x plus 3 and x minus 3. Okay, now the fun part, x plus 3 cancels each other out, x minus 3 cancels each other out, x plus 3, x plus 3, x minus 3, x minus 3. And when I do that, I've gotten rid of my denominator. Okay, so now on the top, I have 2x times x minus 3 plus, oh good, then we won't run into problems, remembering to distribute that negative sign, plus x times x plus 3 equals 18. Okay, multiply 2x times x minus 3, 2x squared minus 6x plus x times x plus 3 is x squared plus 3x equals 18. Now I'm going to combine like terms. I've got 2x squared plus x squared, that's 3x squared, minus 6x plus 3x is negative 3x equals 18. Okay. I can see right away that this is going to be a quadratic equation that I have to solve. And so I'm going to put all of my terms on one side and equate it to 0. 3x squared minus 3x minus 18 equals 0. Now I can also see that there's a common factor in all three of those terms. I could factor out a 3. So that's the same thing as saying 3 times x squared minus x minus 6 equals 0. Okay, Now I have a much easier trinomial to factor. So this is the same thing as saying 3 times. I'm looking for two numbers that will multiply to give me -6 and add together to give me -1. It's going to be x minus 3 and x plus 2. Now remember what I've said before, once you get it to that factored point and you think you're right, always, always, always double check it, multiply it back out in your head and make sure you end up with what you started with. We want to get this. So x times x is x squared. 2x minus 3x gives us this middle term, -1x. And -3 times +2 will give us this -6. So we're good. Now, like before, this term can't be equal to 0. Well, this term actually we're saying is equal to 0, so I guess we would write it that way. X minus 3 equals 0, so x is 3, or x plus 2 would have to be equal to 0. So x might be -2. When we go back to our equation, though, to see what our non-permissible values for x would be, remember we have to look at our factored form to figure that out. And if we look here then at our factored form of our denominator, it's x can't be positive or -3. And if we list that x cannot be positive or -3, we can see right away that this root here, x equals 3, is not possible. So that tells us right away this is an extraneous answer. It's not possible because x can't be 3. And so it tells us then that our answer would be x equals -2, and that our non-permissible values for x are this. All right, one last question to try. I've got x minus 1, x plus 1, and then I've got a denominator on the right-hand side that needs to be factored. So let's start there. We'll just keep everything else exactly as is, copy it just the same as it is. And we'll just deal with factoring this denominator first. So that's also a difference of perfect squares. So it's going to be x plus 1 times x minus 1. Okay, now I can see at a glance that that is also going to be my common denominator, x plus 1 times x minus 1. So I'm going to multiply this side of the equation by x plus 1, x minus 1, and I'm going to multiply this whole side of the equation by x plus 1 and x minus 1. All right, let's apply that. I've got 2x plus 3 times x plus 1 and x minus 1, all over x minus 1. Then I'm subtracting. Ooh, watch that subtraction sign. We've learned the hard way. And maybe that's good that we did, because now maybe you'll be extra careful to watch for that yourself. Okay, so then we've got minus 2x minus 3 times x plus 1 and x minus 1. And that's all over x plus 1. I'm going to just put this all in a bracket so that I don't forget to apply that negative sign to whatever this ends up being in the end. Okay, and that's going to equal 10 times x plus 1 and x minus 1 all over x plus 1 times x minus 1. Okay. This is Baker's favorite part. Do your canceling so you can get rid of those pesky denominators and be left just with your numerators. Okay, so we've got on this side 2x plus 3 times x plus 1 minus 2x minus 3 times x minus 1. Again, I'm going to put that in brackets so that I remember that that's one whole amount that's being subtracted, and that's going to equal 10. I'm just going to move this out of the way so that I have a little bit more room on this side. Okay, so let's multiply using FOIL to figure out how much 2x plus 3 times x plus 1 is. 2x times x is 2x squared. I have 2x plus 3x, that's 5x. 3 times 1 is 3. Minus whatever amount this ends up being. 2x times x is 2x squared. Minus 3x minus 2x is minus 5x. Negative 3 times negative 1 is positive 3, and that equals 10. Okay, now I'm going to apply this negative sign to every term in this trinomial. That's the same thing as saying negative 1 times everything that is in that bracket. So 2x squared plus 5x plus 3 minus 2x squared plus 5x minus 3 equals 10. Now I can combine like terms. I've got 2x squared minus 2x squared. They more or less cancel each other out. 5x plus 5x is 10x. 3 minus 3, they cancel each other out. 10x equals 10, so x equals 1. However, when we go back and look at what our non-permissible values are for x, I can see that x cannot be at positive or negative 1, which is a problem. X cannot be positive or negative 1, so that makes this solution impossible. So therefore there is no solution to this equation. Okay, and that is the end of our lesson. Your assignment today is on a handout, and I'd like you to try those questions so that you have some experience trying some of these on your own.